Okay, so we're setting up a ramp problem. Let's make it so that this ramp has no friction. And starting at the bottom of the ramp, we're going to have an object that starts out and it's moving up the ramp with a speed of v0, let's call it. Oh, I know, we'll do this problem with no numbers. That'll be fun. So this angle looks a little bit like let's say it's an 18-degree angle. And, oh, actually, since we're doing no numbers, we're going to make it a theta degree angle. So the angle is just going to be theta. And this object is going to go all the way up the hill, and then, or it's going to go some distance up the hill. So I guess the first question we could ask, how far uphill will the box go? Guess it doesn't have to be that big. Oh, that's fine. Part B, how much time to go up and come back down to where it started? Yeah, those are some good questions. So what I'm not asking about is the acceleration of the box, but we do need to know what the acceleration of the box is. So how far uphill from this point? So there's going to be the box is going to get up to a certain amount of height. It's going to get up to like up here. And we don't know how far it's going to get. All right, so if you're watching this as a video, pause at this point, see if you can figure it out. The answers are not going to be numbers. They are going to be letters. You're going to be using the letter V0, the letter theta, and the letter G. Answers in terms of V0, theta, and G. You will not have, you'll not be able to use terms like A. You won't be able to use terms like, you can like use them in the problem, but like your final answer is not going to have any of those letters in it. You're going to keep canceling down until you find the answer that has only these letters in it. So go ahead and pause the video and then come back and we'll go over the answer. Okay, so here is the solution. So how far will the box go uphill? That's kind of like a delta x, okay? So we're looking for delta x, or a distance. You could call it d, but in the equations that you guys know, it's listed as delta x. So first we have to know, what's the acceleration of this box? Well, if I draw a free body diagram for the box, then there's going to be mg pulling down. There's also going to be the normal force, Fn. And we've said that Fn has to balance out with m times g times cosine theta. That leaves the part of mg that's pointing downhill, which will be the net force. So if I make my force equation for this object, force equation, and let's make it downhill. Yeah, we'll make downhill positive. Downhill is positive. Then we have m times a unknown equals the part of F. This is parallel to the ramp. So downhill is parallel to the ramp. So only the forces that are parallel to the ramp will be considered. So that's the part of mg that is parallel to the ramp, this downhill part. And that downhill part is m times g times sine of theta, the parallel component of the weight. So then the acceleration will be downhill, divide by m on both sides. We have g sine theta is the acceleration. And let's note that this is downhill. Okay, so now that I know that that's downhill and that it's g sine theta, I'll just put this over here. So we're doing part A. We need to figure out what distance it's going to get up to. So that's a linear kinematics equation. There's no time involved in part A. So Vf squared equals Vi squared plus 2 times A times delta x. Okay, now we can't use letters like Vf in our answer. Can't use letters like A in our answer. We're solving for delta x. So our answer is going to be delta x equals, and then these letters. Okay, so let's plug in what we know. We know that when it's not moving anymore, when it's gotten to its highest point, that the velocity will be 0. And the v initial is called v0, and that quantity is squared. And then we have 2 times a, and a we just figured out, which is downhill. Now, if we put in v0 squared, that's positive v0 squared. So really, if we say it like this, we're making uphill positive. So now I need to write negative g sine theta in here. Okay, so now I solve this equation for delta x. So I'll move v initial to the left side. So v initial squared, and that's a negative, divided by negative 2 times g times sine of theta. I see that these negatives are going to cancel. Okay, so the answer is, how far will the box go up the hill? v0 squared divided by 2 times g times sine of theta. And that's the answer for part A. See, the answer is not a number, but if I did know what the angle, I could do this now. Now I know for various angles and for various starting speeds, how far the box would go uphill. So it's even more valuable than if I had just done this problem with one set of numbers. This is called finding a general solution, which is really, really super valuable. The next question says, how much time to go up and come back down to where we started? So it's going to go uphill, and it's going to reach a speed of 0, and then it's going to come back down. So I'll give you guys a second to work on that. Okay, so here's how you do part B. How much time will it take to go up, come back down to where it started? So yeah, it's going to slide up, and it's going to slide back down to where it started. I'm going to break it into two pieces. I'm going to say the part to go up is going to be a certain phase 1. And then the time it takes to come back down, there's no friction. So it's going to have the same acceleration up and the same acceleration down. So it'll be the same amount of time. So for this, I can use the equation Vf equals Vi plus A times T, where, and now I'm just going to look at half of the motion right now, because if I were to put in, well, actually, one thing I could do is I could get the two at once. I could say, when it's coming back down to where it started, it's going to have the same speed it had, but in the opposite direction. So I could say negative V0 is V final, and positive V0 is V initial. And negative g sine theta is going to be the acceleration, and then time. So this will work. What I'm going to do is I'm going to take the g sine theta and the t, that term, move it to the left side so it would become positive. I'm going to move the v initial negative term to the right side. And what I get is, on the left side, g sine theta times t equals 2v0. So t would equal 2v0 divided by g sine theta. So then that's the answer. 2v0 divided by g sine theta. So the other way to do this would be to say that since the acceleration is the same on the way up and on the way down, we could make the VF equal to 0. We could have just said that this is 0, and then we could double the time that we get, because that would be time to go up, and then we could double that to make it time to come down as well. Time to go up plus time to come down, and if they're the same, it's the same as doubling. All right, thank you very much, and that's all I have for this video.